Yes. And actually, that's a great segue to part of your point that when you moved into this facility, that it's a lease facility, so I'm assuming everything was already built out in that facility, all the electrical and mechanical infrastructure. And you pointed out that the electrical infrastructure was, because it's lightly loaded, there was greater losses on it, right? As electrical equipment's kind of famous for, mechanical equipment as well, where when it's less loaded, you have a lower efficiency. And so as your loading went up, your actual efficiency of those systems went up, so you became more efficient. So if you were going out and building your own data centers, was that the approach you'd probably take, is try to scale in that infrastructure?
We do, yeah, we do that. We, as our building our new data center up in Oregon, we do scale it as, yeah, so what we call it big block, but by suite by suite.
So this way the electrical and cooling capacity is more matched with the IT load as it comes on. So you're not building this out in advance and have this kind of idle or stranded capital expense, but also you're improving the efficiency of each block.
Right, and quite honestly, you know, if you look at the server side, it's quite always changing. Servers, you know, 10 years ago, these servers are much lighter load, and now you see this, you know, up to 8, 10 kW. That's pretty normal. So yeah, it's changing.
Right, and so when you say, yeah, just a minute. Do you say 8 to 10 kW? That means per rack?
Per rack, yeah.
Yeah. So, and that's definitely different than when we're back at Exodus, and even when we worked together at Equinix as well. You know, it's 2 kW or 4 kW.
4 kW, right.
Yeah. So we're seeing a doubling of that, and that's certainly, you know, something we're all dealing with. So maybe let me get to your question and everyone else's questions actually in just a few minutes. Okay. I see there's a lot of them out there, so this is great. I'm glad. Thank you. Just hold those questions. I'll get to them in just a few minutes. This actually, I want to kind of maybe touch on that point with server load. You mentioned you save 3 watts fan load, you know, 3 watts of fan load per server by going back to the manufacturer of those servers and working with them to revise their algorithm so that you could increase the temperature of the server so the fans wouldn't speed up as much. And that's a very novel thing to do, and it's a great way of thinking about it holistically because obviously the servers are what's creating the load. And 3 watts doesn't sound like much per server, but when you add up that times however many servers per rack, right? I mean, give me a little better idea of really what that amounts to.
Yeah, so you saw that number there, a total of 276 kW saving in demand, and the cry units was basically 114 kW. So you can see the delta is just huge when you add up all these little numbers, because you got 40, typically you got 40 servers per rack, and the data center you'll have, you know, 500-600 cabinets. It adds up really, really fast.
So a good point is that even 3 watts is worth looking at, right? Especially when it's 3 watts times thousands of 3-watt devices. And so even these little things that we kind of often forget about, because we think about the big things, right? The chillers, the CRA units, you know, adding VFDs to the big pumps and fans. But even all these, now as we start to keep improving our efficiencies, we have to keep looking for those little things. And sometimes those little things add up to a lot, like in this example.
When you buy these servers, they're preset it such that the fan will be running 100%. Just because manufacturers typically, because of the warranty issues, right? So they will run it 100%. But you can actually use the software firmware to lower the speed down, because the servers can be actually run at a much higher temperature, wider humidity.
So let's kind of talk about some of those details. You increase the temperature, the supplier temperature, from 72 to 81 Fahrenheit. Is that correct?
No.
No, that's written on CRA units.
The return on the CRAs. Okay.
So actually the supply temperatures for the servers were in the range of 57 to 65 when we started. And at the end of these activities, we were able to change that range into higher 60s, 68 to around 74. That's the range that we have air supplied to the servers right now.
Okay. So when you said you worked with your server manufacturers to work with them to revise the algorithm, were they fairly accepting of that change?
Yes, they were. And we actually went a lot of time back and forth in that. Eventually, they came to our data centers. We had some of the systems instrumented, got the data, and then they gave us the firmware update. Many times, it always is that how much you are willing to share. Okay. In this case, we were able to give them access to what is our Facebook load, and then they were able to match sort of the fan speed requirements to our load. So it is, we talk about matching the cooling to our demand, so it is done at the server level. That's what we did there.
And server level, server load actually changes depending on your application as well. So our Facebook application may be different than eBay application, and that changes as well. So you're gonna have to look at the application and look at the thermal, how the server behaves based on that.
Great. Well, I know there's a question out there, so I'll take your question first. Then we'll get to you, and then Bruce. Yes, and whomever else out. Would you please stand and actually say your name and what company or organization you are affiliated with before your question?
My name is Norm Ringgold. I'm head of IT operations at Slack National Accelerator Lab.
Here's a microphone coming to you. Would you please say that again, just so everyone can hear?
My name is Norm Ringgold. I'm head of IT operations at Slack National Accelerator Lab, Stanford. So if you've convinced the server manufacturers to change your algorithm, giving you that lower fan speed, did they also give you a revised manufacturer spec? Meaning, for this particular server, you require this much peak power. Because normally we'd build out a row to accommodate peak worst case scenario requirements, right? Even if we're not going to use that power, worst case scenario, if everything's powering up at once, we need to spec to this, otherwise we blow breakers, worst case scenario. So that's my question. Did you either get one from the manufacturer, or did you revise per your own specs what peak would be?
Thanks for your question.
So what we did is, to answer your question, yes, from the server perspective, they will tell you that. But we actually loaded our application and run that server, and we monitor that load, how that load changes. So we show that graph to work with the OEM vendor. Here's what we have with the peak, and here's the average. So can we reduce that fan speed? And the answer was yes.
So you were able to build per that new spec?
Correct, per our spec, yes.
So, and one thing maybe to point out, and yeah, Prajesh, we'll get to your question as well, is that this is what you did in this leased data center, right, that you already were populating from some time ago. So it sounds like that's something now you can work on as far as your specification for all new server purchases, right, and other hardware. It doesn't have to be just servers. It could be switches. It could certainly be storage devices as well.
That's correct.
Yeah. Great question. Let's go ahead and take this question here. Pepe, great to see you. Yeah, thanks for coming all the way out.
Pepe Castells with Savvis. Actually, I have two questions. The first one, I see both you guys went with cold aisle containment. And in cold aisle containment, in the studies I've done, when you have that utility failure and, you have 10, 15, 20 seconds before you have any cooling, that you starve your servers. Did you guys look at that at all?
Yes.
And that's a great question for Rich as well, because you also did cold aisle containment.
Right.
So Rich, let's start with you.
So that was a big concern for us. Obviously, as we increase densities in the racks and being able to respond, we did see obviously a reduction in time to live, if you will, and worked with our mechanical engineer to increase the cold aisle. So a typical 48-inch cold aisle, we went to a 6-foot model, and using the containment methods that we have, are able to keep the time to live at an acceptable, I will say an acceptable time frame, so that we can recover. But it is something that we looked at, as opposed to pulling the hot air out in a hot aisle.
Did you actually test it?
Yes.
And what type of temperature rise did you get inside there? It had to be pretty high.
Gets hot quick, but because it's not a fully contained design, so it is open on the top. You'll notice on our cold aisle containment design, it's 24-inch say containment material or wall that is around the top of my server, so I still can pull in or draw in from ambient temp if I need to.
I see that. Yours was completely closed, wasn't it?
Right.
Yeah, we were closed.
So again, it ties to the algorithm, fan speed control algorithm, and the server fans would speed up in that scenario, and they would take out, yeah.
Yeah.
And the one other question, I saw you made your return temperatures go up to 81 degrees on a Liebert. If you're getting 81 degree coming back and your valve doesn't open at all, how would you keep it from bypassing 81 degree air back into your system?
Right.
You know,
So in our case, what we did when we selected these cry units, we selected them in a way that those are the ones which are not required in that particular suite, and all other cry units were essentially carrying the load. As I indicated, we have sensors deployed on the cry units as well, and we monitor supply and return temperature for all the cry units in all the data center. And till now, we never ran into situation where one of the cry units was delivering that much for longer period of time. And essentially, since it's underfloor plenum, the rack inlet temperatures are mix of couple of cry units. So basically, each row is influenced by a couple of cry and not single cry unit.
So these are really good questions, Pepe, and also very good follow-ons. And one thing I like to point out is that in both cases, these data centers are mission critical, right? They are essential. And you know, if you know a 15-year-old, they cannot live without their Facebook for a minute. And you certainly, if you got an eBay transaction you want to make, and you're bidding on something, comes down to close, you have to make it, right? You can't mess that up as the company. So in both cases, these were mission critical. So you analyze that in both cases, that you were okay making these changes and still maintaining the critical availability of your servers in those data centers.
Right. To answer Pepe's first question, to add that comment to the fans, those are PWM fans. So they're controlled by the thermistor in the server. So as you set that thermistor temperature, that fan will ramp up and ramp down. On the normal operation, if we set it, let's say, what is that?
77.
Yeah, 77. So depending on how you set it up, the fan will ramp up and ramp down. So you're right. I mean, it's a risk when the utility power is lost. Only air you're going to get is through the perf tile. So yeah, it is a risk. But we have done some tests, and it didn't seem to fail any servers.
And I can add on a little bit to this as well. As I used to be at Yahoo, and we started pushing air economization as well, and really trying to push the elevated temperatures. Bruce, I'll get to your question. Yeah, you're next.
Yeah, okay.
And we tried to push those elevated temperatures as high as we can go. We really wanted to push it above 80 as far as supply air temperature to the servers. But we noticed when we hit 77 degrees as the supply air temperature at the servers, that the fan speeds on those servers ramped up. Yeah. And all of a sudden our UPS load went up, which is, of course, a negative consequence of trying to save some energy in the mechanical system. And they start countering each other and become counterproductive. So we had to do the same thing, and that's work with the OEMs, the server manufacturers, to allow us to run an elevated air temperature, supply air temperature to those servers in order to make sure that we weren't being counterproductive pushing those higher supply air temperatures. So yeah, there are a lot of nuances. We don't always think about this when we have these, implement these, call it infrastructure-related energy savings initiatives. They sometimes have a negative effect on the hardware side, and we often do forget that the hardware is still the biggest component of, usually in most data centers, of the total load. So it's still essential that we really look at that and manage that well. So Bruce, you've been very patient. Let's go ahead to your question.
And that's unusual too.